Hey guys, welcome to the next video on syn and anti-addition. This one is going to be specifically focusing on H2PDC and the kind of tricks that they may use against you guys to try to trip you up on the test. And this is mainly to try to prepare you for something like that. Okay? And so what I wrote that, right here is a very common thing that you can see on exam 2, whether it's a standalone question or maybe even a roadmap question. All right? And so you can see here that they gave you H2PDC and a final product with some sort of stereochemistry, okay? And so they want you to figure out the reactant. So let's just say X, all right, molecule X. They want you to figure out what the original starting reactant was. So what you guys need to do here is you need to think a little bit, all right? So you know that H2PDC is going to be syn addition, so that the hydrogens must be the same on the same side, right? It must be either wedged or dashed, both of them. And so let's think first where the hydrogens probably added. You can see that it was probably going to be added to these two carbons right there. Okay. And so what we're going to do is we should draw in the hydrogens. Okay. And so let's make these hydrogens, we're going to focus on blue. All right. And so let's just draw them in. So you can see on the carbon with the wedged methyl, the hydrogen is going to be dashed. The carbon with the dashed methyl, the hydrogen would be wedged. So, this is an interesting problem. You can see that the hydrogens are for some reason opposite stereochemistry. Why the hell is that even possible? We know that it's syn addition, it's not anti-addition, right? But what I want you guys to do is I want you guys to think about single bonds. I'm thinking about a specific feature of single bonds, okay? If you want to figure it out for yourself, please feel free to pause the video right here. All right? So if you guys remembered that single bonds allow something called free rotation, all right? They are allowed to freely rotate, and that can change the orientation of the molecule or the configuration. Okay, and so we know that H2PDC addition is syn. So we know that the hydrogens should have added to the same side of the double bond, which means by default those methyls should also have been either both wedged or both dashed. But it's not. Everything's opposite. So one possible explanation is that the whatever our original molecule was, compound X, we added the hydrogens, and it was syn at that point, and then it underwent a bond rotation to give us this compound, where it looks as if it was anti. All right, and so let's try to rotate the bond. And so if we see, we're talking about this bond right here in red. So I'm going to take half of the molecule, and I'm just going to rotate it 180 degrees. All right, and so the trick for rotating something 180 degrees is all the planar bonds, you just flip it upwards, and so it's going to look like this. So 180 degrees. And so I'm going to just kind of flip the left-hand side, so keep the right-hand side the same. So like this. All right. And flip the left-hand side. So let's just number the carbons to be safe. 1, 2, 3, 4. Remember carbon 1 there. And let's now flip them all up. So this is going to be our carbon 2. And then are going to be carbon 3 and 4. Just get some space. Okay? And so that's how we just rotated that bond. And you can use the obviously model kit to help you, but again, on the exams, I would recommend that you can be able to do this without a model kit, but it's whatever helps you guys. And so that's how we deal with the planar bonds. Now, in terms of wedged and dashed, think about it for a moment. Let's look at the wedged carbon. It's pointing upwards and wedged, which means it's, again, upwards, and wedged means it's coming at you. So take a pen and just kind of orient it so that the tip of the pen is aimed right at your face, okay, coming upwards. And now take that pen and rotate 180 degrees, and so it's going to be now pointing down and away from you. Away from you means dashed. So that carbon is now going to be dashed and down. And in terms of the dashed hydrogen, it was originally pointed up and away from you, which is dashed, right? So take a pen and point it on facing slightly upwards and away from you. And now flip that 180 degrees. It's going to be coming downwards and towards you, which is wedged. So we get this now. All right. Now it looks exactly syn. The hydrogens are wedged, and those methyls are dashed. Right. Exactly what the syn reaction would look like. And so what we can now do is now we know exactly where the original double bond was. Right. It's just going to be between that carbon, and now we can draw it. And so the original structure looked like this. All right, that's the original structure. If you were to have answered it on the methyl, sorry, like that. If you were to have just done it like this, that would have been incorrect, because the syn addition of that would look something like this, or the dashed version of that. All right, that would have been incorrect. Also, let's just realize something here. Why did they only draw one version of this compound instead of the other one, where we could have had the hydrogens, the complete opposite stereochemistry, so that carbon that labeled as carbon 1, why couldn't we have made that methyl dashed and reversed everything else as well? Well, it's easier to see it when I drew it this way, that this is a meso compound. It has an internal plane of symmetry right through there. So it's an achiral compound. It's got no enantiomers and stuff like that, so it is achiral, right? It's just a meso compound. So that's why they only drew one. All right, and so watch out for stuff like this in terms of H2PDC. Now, obviously, they don't have to limit it to H2PDC. They could very easily have done something where they took an anti-reaction, something like Br2 over H2O, which in an anti-reaction, Br and OH would have had opposite stereochemistry. And they could have done a bond rotation to have the Br and OH the same stereochemistry. And in that case, you would have had to rotate it again to get the Br and OH opposite. All right? And so just keep that in the back of your head. Remember, it's still what you think. Use what you know. You know that certain reactions are syn and certain reactions are anti. All right? And so I hope this video helped you guys. If something is unclear, please feel free to email me or to go to the CLC. If you're watching this on YouTube, please feel free to comment below your question so that someone who has a similar question to you may also get theirs answered at the same time. And I will see you guys in the next video. Good luck.